In exercise 305, we're going to talk further about the magnitude and the direction of vectors. So given the vector u that's equal to xy, the magnitude we've already seen is Pythagoras' theorem, the square root of x squared plus y squared. Now the direction, we can use a little bit of trigonometry. So tan of this angle here, this angle gives us the direction, is equal to opposite over adjacent y over x. Now you do need to make sure that you draw a graph, you draw a bit of a diagram, so you're making sure that you're in the correct quadrant. So you may need to add 180 or 360, I'll put that bracket later. Now theta is always given between 0 and 360 for vectors. So let's look at this. So given OA, this vector here, is equal to x1, y1. And OB is x2, y2, the magnitude of AB, this vector here, that can be found with the distance formula. So we've got that one squared plus that one squared, and we're taking the square root of that. So x2 minus x1 is that distance that we can see down here, and y2 minus y1 is this distance which we can see over here. So that's the distance formula. The direction of AB, now think of it up here, so it's this angle in here, again is tan theta is equal to y2 minus y1 over x2 minus x1 opposite over adjacent. Always make sure, as I said, to draw a diagram. I'm going to keep repeating that. So let's look at some examples. So given OA equals negative 5, 1, and OB equals 3, negative 6. Find the magnitude and direction of AB, so this vector here. So if I draw this, I'm looking for that angle there. Okay, that's really important. So let's have a look. So first of all, that angle happens in quadrant 4. We are going towards quadrant 4. So that's really important. Our final answer has to be between 270 and 360. So the magnitude of AB, Pythagoras' theorem, distance formula. So 3 minus negative 5, 1 minus negative 6 are our squares. So, and that comes from up here. So x2 minus x1, y2 minus y1. And that equals the square root of 113. That's the magnitude of the vector AB. We know that tan theta is equal to y2 minus y1 over x2 minus x1. So that's negative 7 on 8. So of course tan inverse to find the angle, and I got negative 41 degrees. So it's given me this angle here is negative 41. Because we're in quadrant 4, we need to add 360. You're always going to add a multiple of 180. You're either going to add 180 or you're going to add 360. If you're not in the first quadrant, if you're not between 0 and 360, if you're not in the right quadrant. So the final answer is 319 degrees. Now I'm going to show you a second method for that one. So we know that OA was negative 5, 1, OB was 3, negative 6. So AB is equal to OB minus OA. So let's go ahead and subtract them. So we get 8 and negative 7. So our x is 8, our y is negative 7. Our magnitude is, of course, the square root of 8 squared plus negative 7 squared. So by finding the vector AB first, I don't need to use the more complicated formulas. I can use the more simple ones. And that's the square root of 113 again. Tan theta is just negative 7 on 8 now. So it's exactly the same thing as up here. We're just kind of getting to skip those steps by finding AB first. So instead of using these numbers, we're just using the numbers for AB. So theta equals negative 41 again. Of course, we need to be in the correct quadrant. I have not drawn a diagram here, and that is really, really, really important to draw a diagram. We only know it's plus 360 because that's what we had to do in method 1. So 319 degrees to the nearest degree. So let's look at each of these, finding the direction of each of these. Now, to begin with, I'm not going to consider quadrant. So I'm just going to do theta equals tan inverse of 2 on 3. So it's kind of upside down. And that gives me 33.69 degrees. For W, tan inverse of 2 on negative 3. That gives me negative 33.69. Now that's not between 0 and 360, so that's a big alarm bells. P is tan inverse of negative 2 on negative 3. So that's 33.69 degrees. Again, that's the same answer as the first one, but clearly these two are not in the same quadrant. And for the last one, tan inverse of negative 2 on 3, which gives me negative 33.69 degrees. So you can see they're all 33.69, some are positive, some are negative. But to find the actual direction, we do need to consider which quadrant they're in. So I've drawn that down here. So V, our direction is just going to be 33.69 degrees. That angle right there. For W, we need this angle. W is in the second quadrant. So we had negative 33.69, which is down here. We need to add 180 to get into our second quadrant. So 146.31 is the actual direction. For P, we're in the third quadrant. Oops, annoying the way it does that. P, we're in the third quadrant, so it's this angle here that we want. It gave us 33.69, so it gave us this one. We want this one. So again, we need to add 180. We get 213.69, and for the last one, we got the negative 33, so we need to add 360 to get into that fourth quadrant. So let's just talk about how to do this in our calculator. So a vector can be given in what we call polar form, which is the magnitude and the direction, as opposed to rectangular or Cartesian form, which is like 3, 2 in brackets like this, or 3i plus 2j. So to put this into polar form, the first thing we do is shift plus, and we'll get a POL for polar on the screen. So you're telling it to polarize this thing. So shift plus, then put the 3, then we need a comma, and that's a shift close bracket. Put in the 2, close your bracket, press equals. You don't actually need to close the bracket. And that's the answer you get. Now you may get lots of decimal places. You can arrow right to left to be able to read the whole thing. Now to go from polar form into rectangular form, so this vector has a magnitude of 2 and a direction of 60 degrees. So that's that special triangle we've seen before. It's that vector there. So we go shift minus first to say put it into rectangular form. You press the 2, then we need a comma. So shift bracket for the comma. Then the 60, close the bracket, equals. And you get this. Now, that 1.7, of course, that's root 3 on 1. Tan 60 is root 3 on 1. Root 3 is equal to 1.7 ... So I just wanted to actually do this on a calculator. So the first one was shift plus. Oops, shift didn't work. Shift plus to put it into polar form. I had 3, then shift, comma, 2, close the bracket, press equals, and you can see there that's quite a nice display. When I actually did it on my calculator, it had these side by side. I couldn't see them quite so easily. I did have to use these arrows to go left to right to read them all. So that's putting 3, 2 into polar form. Now let's go the other way, so I'll just clear that. So shift minus for rectangular form. 2, shift bracket for comma, let's go 60 degrees, close the bracket, press equals. So x is 1, my magnitude is 1, and that's because it's the horizontal line at the bottom of the triangle. My y is equal to the 1.7, that's the vertical line of the triangle, that's the square root of 3. So 1 across, square root of 3 up for those rectangular coordinates.